Example 3.20. Use Laplace transform to obtain the charge Q. So look at the equation here. The variable is Q. Q means the charge at any instance of a capacitor which is discharged in RLC circuit. Suppose R equal to 2.25. So now you have the value for this parameter R. Self-inductance 1 Henry. So L is also given. C is 2 farads and the capacitor initially has a charge of 100 coulombs. Okay, so let's rewrite the expression by substituting the value. L is 1, so the equation is d2q dt square. R is 2.25 dq dt plus Q over C. C is 2, okay, equal to Ft. Okay, we don't know Ft yet. So let's transform this sentence into mathematical formulation. And the capacity initially has a charge of 100 coulombs. So this is the initial value, okay, initial value where we have at time 0 the value of Q is 100 coulombs. Next, initially the switch is open and therefore no current is flowing. How to transform this into equation? Initially means that at t equal to 0 no current is flowing, means that the dq dt no flowing, so it means like this, dq dt 0 equal to 0. Okay, next, the RLC circuit is modeled as second order ordinary differential equation and its general equation which follow Kirchhoff's second law satisfy the following equation. Okay, so this is what we have. So no info for Ft, the external force, so means that Ft is 0. And we have two initial conditions. The first one is this, Q0 equal to 100. And another one is about the no flowing situation at time equal to 0. Right? So here dq dt 0 you can rewrite as a q prime 0 equal to 0. It has the same meaning. Both representation give the same meaning. Okay, so let's solve this by using partial fraction. By using Laplace transform. Okay, so to apply Laplace transform you have to put L on each term. Laplace of the first term plus the Laplace of the second term. So now it's obvious 2.25 is just a number, so I can put this outside. So what remains in the Laplace braces is just this. And for the third term, I can see that over 2 is just a number, so I can put 1 over 2 outside. So the Laplace of Q only. On the right is the Laplace of 0. So we want to solve this equation. Now note that we have the Laplace of the second derivative. By looking at the formula of the second derivative, okay, we have Laplace of f double prime equal to s square fs minus s f0 minus f prime 0. So now since we use q, so every f will be replaced by q. Capital F become capital Q and so on, right? So you can write the second order, second derivative for the Laplace is s square qs minus s q0 minus q prime 0. So means that this, the first term, will give you 3 terms here. Then let's put at 2.25. This is the Laplace of the first derivative. Okay, so you have to apply for the first derivative. The Laplace of the first derivative is SFS minus F0. Remember, we are using Q, so means that we can put a big bracket representing the Laplace of dq dt as QS minus Q0. Now, the third term is the 1 over 2. Laplace of Q is just capital QS. Laplace of 0 is 0. So from here, we have to simplify. By applying the condition, we can put Q0 here is 100. Q0 here is also 100. And Q prime 0 is 0. So simplifying this, you will get 100s plus 2.25s QS minus 100 times 2.25 is 225, right? Plus 1 over QS equal 0. Okay, now we want to factor Q. So make a bracket here, s squared plus 2.25s plus 1 over 2, you can write as 0.5, right? QS, and the remaining part should be pushed to the right. So it becomes 100s plus 225. Now QS is 100s plus 225 over this bracket. Okay. So look at the denominator here. We have s squared plus 2.25s plus 0.5. So let's put it in. Let's factor this. Okay, let's factor this. What you obtain if you factor this? One way to factor this is to transform the decimals into fraction. 2.25 in fraction equal to 9 over 4. So let's replace this to and we want to write in fraction form. And 0.5 remain as 1 over 2. Okay, so how to simplify this? Since the function here we have 9 over 4s, we can solve by simplify by multiply 4 because you want to remove the denominator part. So on the upper fraction you have to multiply by 4 as well. So now it becomes 400s plus 225 times 4 is 900 over the denominator become 4s squared plus 9s plus 2, right? Now you can factor the denominator part. Let's factor this. This is 4s plus 1 s plus 2. Okay, now so this is your QS. We want to find QT, right? QT is the Laplace inverse of capital Q. So look at this form. This is fraction and we have a factor on the denominator. So the best technique is to apply the partial fraction. So 400s plus 900 over this factor can be written by a over 4s plus 1 plus b over s plus 2. Okay, so we want to write a and b. We want to find a and b. So your a value should be multiplied by s plus 2, and your b value should be multiplied by 4s plus 1. And this is equal to 400s plus 900. After that, we want to expand and the right hand side remain the same. Next is to factor the terms that has s. Okay, so now your a plus 4bs and the remaining term is just 2a plus b equal to 400s plus 900. Next is to comparing the term of s with s. So now your a plus 4b equal to 400, right? And your 2a plus b equal to 900. So this is a system consisting of two equations with two unknowns. By using calculator, you can solve this simultaneous equation and you will obtain a equal to 3200 over 7 as a fraction, and your b is negative 100 over 7. You can derive this. So now your fraction, your partial fraction, your qs is a over 4s plus 1, which is 3200 over 7 over 4s plus 1 plus b minus 100 over 7 over s plus 2. So since it involves multiple part, so this can be written by like this. Alright, now it's time to find the inverse Laplace transform. Okay, so to find qt, you have to find the Laplace inverse of qs, which is the Laplace inverse of the first term, 3200 over 7 4s plus 1 minus Laplace inverse of 100 over 7s plus 2. We know that this is just a number 3207. This number can be taken outside, so you can write like this. So the remaining part is just 1 over 4s plus 1 minus 100 over 7 Laplace inverse of 1 over s plus 2. Now it's time to refer to the table of Laplace transform. Okay, we don't have this kind of expression for s plus 1. We want to remove 4. So to remove 4, you have to do the following. So it becomes, we can take 4 outside. So what I mean here is we want to solve this part. Okay, let's move 4 outside, so it becomes s plus 1 over 4, right? So this is what we want to apply here. So I will rewrite this statement on the next line. 4 is taken outside, so s over 1 over 4 minus the same terms. Okay, next, 4 is also a number. We can take it outside as well, right? So by combining to this with this and simplifying, you just need to do like this, cancel and simplify, so it becomes 800 over 7, and the Laplace of what it is, right? And the remaining part is just the same. Okay, let's find the Laplace inverse of 1 over s plus 2. It is straightforward. It is obvious that we need to refer the row of exponent. So e negative 2t. Okay, so for this part, 1 over s plus 1 over 4 is just another, this is the value of a as well. So what we want to refer is this row, right? So your a is 1 over 4, so now you can write as e negative 1 over 4t, and combining to the second term. Now this is the final answer of qt. Okay, this is qt.